Welcome all. I'm Nisha G. Krishnan, Assistant Professor, Department of AC, Rohini College of Engineering and Technology, Kanyakumari. We're discussing about electronic devices and circuit. Let's start with
Welcome all. In this video, we will learn about bipolar junction transistor. On completion, students will able to demonstrate how a BJT can be used as a voltage amplification and demonstrate how BJT can be used as switch. Bipolar junction transistor. The basics of electronic system nowadays is semiconductor device. The famous and commonly used of this device is BJT. It can be used as an amplifier and logic switches. The BJT consists of three terminals, that is collector, base and emitter. Two types of BJT are PNP and NPN. The PNP type transistor has a single N region between two P regions. The middle region of each transistor type is called the base of the transistor. This region is very thin and lightly doped. The process by which impurities are added to a semiconductor is called doping. The remaining two regions are called emitter and collector. The emitter and collector are heavily doped, but the doping level in emitter is slightly greater than that of collector. The collector region area is slightly more than that of emitter and it helps in better power dissipation. The PNP transistor has its bias voltage VEE and VCC reversed from those in the NPN transistor. This is necessary to forward bias the emitter bias junction and reverse bias the collector base junction. The forward bias EB junction, that is emitter base junction, cases the holes in the P-type emitter to flow towards the base. This constitutes the emitter current IE. As this holds electrons through the N-type base, they tend to combine with electrons in N region. As the base is very thin and lightly doped, very few of the holes injected into the base from the emitter recombine with the electron to constitute base current IB. The remaining large number of holes cross the depletion region and move through the collector region to the negative terminal of the external DC source. This constitutes collector current IC. Thus, the whole flow constitutes the dominant current in the PNP transistor. An unbiased transistor means a transistor with no external voltage is applied. Obviously, there will be no current flowing from any of the transistor LEDs. Since transistor is like two PN junction diodes connected back to back, there are depletion regions at both the junction, emitter junction and collector junction as shown in the figure. During diffusion process, depletion region penetrates more deeply into the lightly doped side in order to include an equal number of impurity atoms in the each side of the junction. The depletion region at emitter junction penetrates less in the heavily doped emitter and extends more in the base region. Similarly, the depletion region at collector junction penetrates less in the heavily doped collector and extends more in the base region. As collector is slightly less doped than the emitter, the depletion layer width at the collector junction is slightly more than the depletion layer width at the emitter junction. Barrier voltage is the voltage necessary to cause electrical conduction in a junction of two dissimilar materials. The input characteristics is the curve between an input voltage VEB and the input current IE at constant collector base voltage VCB. The emitter current is taken along y-axis and emitter base voltage along x-axis. The output characteristics of the BJT is the curve between collector current IC and collector base voltage VCB at the constant emitter current IE. The collector current is taken along y-axis and collector base voltage magnitude along x-axis. The output characteristics has three basic regions. that is active region, cutoff region, and saturation region. First one is active region. For the operation in the active region, the emitter base junction is forward bias while collector base junction is reverse bias. In this region, collector current IC is approximately equal to the emitter current IE and the transistor work as an amplifier. In the active region, the collector current is essentially almost constant. In the saturation region, in this region, the emitter base junction and collector base junction both are forward bias. That is, VCB is negative, and here the IC is independent of IE, and IC decreases rapidly as VCB become more negative. Next is cutoff region. The region below the curve IE is equal to 0 is known as cutoff region, where the collector current is nearly 0 and the collector base and emitter base junction of a transistor are reverse bias.